A second way in which Python simulations can be useful is to derive the properties of estimators. So things that you've seen in statistics you can actually simulate using Python. So let's consider the following piece of code. So I'm going to define this vector muse. So from TensorFlow we use the random library and then the normal distribution. And I'm going to have 10,000 rows and 25 columns. So I'm going to be drawing from this normal distribution with a mean of 100 and a standard deviation of 10. So I'll turn this into a NumPy array. And then I take a mean. And I take the mean across the columns. So what I'm doing here is that out of this normal distribution with a mean of 100 and a standard deviation of 10, I draw a sample of 25 units. So I have a sample size of 25, and then across these columns, so I have 25 columns, I have 10,000 rows and 25 columns. Across these 25 columns, so axis is 1, I calculate the mean. And I repeat this experiment 10,000 times. So I have this sample of 25, I calculate the mean, and then I do this 10,000 times. So if you look at Muse and you want to know what the shape is of Muse, it takes a while to get these 10,000 things done. You can see that Muse has 10,000 values. Yeah, so I have this experiment of drawing a sample of 25 units, and I do this 10,000 times. So one way to look at this is to say, what is the histogram of Muse? And let's say that I want to have 30 bins. Then this is the histogram that you're going to get. Yeah, so most of the mass is around 100. Yeah, so on average, the average mu is 100, but of course there is some variation around this. Now one thing we can do to get an idea of this variation is to actually use NumPy's standard deviation function. So what is the standard deviation of these mu's? And this turns out to be around 2. Yeah, so for you the question now is, where does this 2 come from? I've drawn 25 units, sample of 25, out of a normal distribution with a mean of 100 and a standard deviation of 10. And when I calculate the mean of these 25 units, I get that this distribution has a standard deviation of 2. Yeah, so the first question is, what is this 2 called in statistics, and y is equal to 2, which equation is actually underlying this, because you can calculate this analytically as well. You can show that it is exactly 2, while Python here gives an approximation that it's close to 2. Yeah, you can also do other things. So suppose we have 25 observations, and the average of these 25 observations equals 104. Oops, 104. Your hypothesis is that these observations were drawn from a normal distribution with mean 100 and standard deviation equal to 10. The question now is, would you reject this hypothesis? Yes, you probably know how to do this analytically. At least I hope you're able to do that. But we can also do this using Python. So what we can calculate is how often is it the case that μ's had the value in excess of 104? Yeah, because actually our vector μ's was generated with exactly this mean of 100 and standard deviation of 10. So how often did it happen that μ's was bigger than this compared to the length of this vector μ's? And it turns out that this happens approximately in 2% of the cases. So then the question is, would you accept the null hypothesis that these 25 observations which had a mean of 104 were drawn from a normal distribution with mean 100 and standard deviation equal to 10?